Welcome back to Arcade. I am Super Tommy, and this is a series on creating a dungeon crawler in Phaser 3. So in the last video, we added a lizard enemy. Just bring him back. He's walking around in this world by himself. Here he is, and we've made him walk around randomly, and when he hits walls, he'll change direction. Now, we need to implement hitting the enemy with our character, which is our character. The camera follows her around, but they don't do anything when they run into each other. So in this video, we are going to implement that. So how should we go about this? Now, this video uses TypeScript, and we've been doing slightly more advanced work, let's say. And one of those things that will probably make this easier for us is if we created a separate class for our player. But before we do that, let's actually just see what the logic will look like. So first thing, we're going to add a collider between the lizards and our player. So add collider, this is in our game scene, lizards and our character. And we're going to want to handle, that's lizards, and we're going to want to handle what happens when that occurs. Right, so let's make a callback here, handle player lizard collision. And I believe we're going to get the lizard first, but I could be wrong. Let's just say object 1, object 2, they will be phaser.gameObjects.gameObject, phaser.gameObjects.gameObject. Okay, this dot handle that undefined for the process callback. We're not going to do any special processing. And then context is this. If you need clarity on what context means, we have a video called JavaScript Scopes and Context Explained in the context of Phaser 3. So do check that out. I will link it in the description notes below. Now we have that. Let's real quick here do a logout of whatever object 1 is, and then log out what object 2 is. So let's give it a C here. Run into me. Okay. I'm being pushed. Okay. So this is the lizard. Lizard is object 2, it appears. Okay. Fantastic. Okay, so lizard is going to be object 2 as lizard, and then object 1 is our player, but we have a class reference to it anyway. Okay, so what we're going to want to do is move the player when she gets hit. So let's just refresh this. Show. So if the lizard hits the player on this side, we're going to want to bounce to the left. If the hits from right, bounce to the left. So what we know, or we can get rather, is the direction vector of player to lizards. So this dot x, and then the lizard dot x, and then y dot y, lizard dot y. So we know that, and we're going to want the player to move that way. So let's call this a directional vector, new phaser dot math dot vector to dx dy. Let's normalize it and then scale it. So let's say we're gonna bounce the player, I don't know, 200, let's say. So this dot faune dot set velocity dir.x dir.y when it gets hit. So you're gonna see, this is not finished yet, but I'll just show you what happens here. Hit me. Oh, maybe I should reverse this. I know. Well, that's a problem. Typos. Well, I could have it reverse as well. Did I do something wrong? Let's try lizard. Is that right? X minus may actually be. I may probably should have reversed this. Although I could also invert the vector if that is the case. I get this confused sometimes. I gotta like take a pen and paper and like draw it out. Okay. Nope, it's not it either. Let's see. It may. Okay, let's see. Oh, yes, I know why. So we do set velocity, but then of course we're having no keys down, and so we set velocity back to 0. So she's not gonna move. All right, so we're just gonna hack this real fast before we put this logic into a class. So we just call this hit 0. It's gonna be a frame counter effectively. We're not gonna keep it this way, but just so that we see this working. This dot hit 1. And then right here, if this dot hit greater than 0, return plus plus. Well, let's not do this yet. You'll see. Okay, run into me, lizard. Whee. Okay, so obviously just the velocity never changes after we set it from 200 scale. So this is just like a quick hack for this. If 10 frames, we are going to, yeah, let's see. We're not going to keep it this way, but just to make it work, there we go. She gets hit, back, boom, boom. There we go. And she'll, depending on where the enemy is, she goes the inverse, I guess it's called, or the invert, the opposite direction. Yeah, wherever the lizard and her was. So that looks pretty good, but this is of course quite not good. So we have this logic working. Now let's actually create our class for the player to encapsulate some of this logic. Let's see. Let's make a new folder called characters. You never know, you may want to have multiple characters. Faune.ts. I really hope this is called faune. That's what I've been calling it. If anyone knows, do correct me in the comments below. Like those dictionaries, how you pronounce words. Okay, export default class faune extends phaser.physics.arcade.sprite because she is a arcade sprite. Constructor super scene XY texture. So I'm just basically using the IntelliSense to help me know what it is, and then I write it out here for reference when I redo it up here. That's why I write that stuff out. Let's see, string frame optional string number. Okay. All right, so we now, let's see, go back to creating our main character here. We set the size. So let's set the size here. Just be this. Oh no, the body. Okay. Let's at least make this. We're going to do this in a separate place. Let's go back to game. We can set this, so that's good. Let's just move this up here. But when we do change this, it'll be easier. Okay, so just like the lizard, we're going to set the animation to her idle down to start. Okay, so we have that. Before we get too far, let's make sure we can create her in the scene this way. So I like to use the game object factory so that inside the scene here we can do this .add.faune, for example, which of course doesn't exist, instead of doing a new faune. So I'll just show you how that works. So in this file, we're going to do phaser.gameObjects.gameObjectFactory, and there's a static register method, and we can register a key, which is what we can use for this .add dot. That's the key, and then this function, and this is a TypeScript thing. This is a gameObjectFactory, and then it's going to take, I believe, X, Y, texture, string, frame, string, number. So this is similar to the constructor. Okay. So now we have this function. Let's collapse this. We have this register function. And what we're going to need here, what I often like to do is I go to physics factory, since that's how we're adding font now. There is the add, sprite, right? And let's just see what Phaser is itself doing. So there's a display list, there's an update list, and there's the physics that it does. So let's just take this. It's going to be similar to this, but not exactly. Let's see if GitHub Paste works. Not bad. Okay, so we're not creating arcade sprite, we're creating a font. And in this case, we call this texture and texture. Okay, and then it's not sys, so how do we know what's on this? Well, there's this, right? And there is a display list. And that works because in TypeScript, we can specify or we can tell TypeScript the type of this inside a anonymous function. That's what we're doing here. And so we can just do that. Phaser uses this.sys because inside the arcade factory, that's how we can access the update list and the display list. And okay, this scene word.physics.world enable body, and in our case, we don't have const. This is required in Phaser's source here. Where is it? Right here. We can access it here though. Physics.arcade.dynamic body. Okay, I prefer not to have semicolons. Some of you may like it. Some of you also may like double spaces versus tabs, or two spaces versus tabs. I like tabs, and I don't like semicolons. It's just a matter of preference. Some people will go to war over it, but that's not me. Okay, we have this set up. This means we can now do this.add.font, but to help TypeScript out, to let TypeScript know that this does exist, we're going to add a little global type here. Namespace. So this is using declaration merging feature of TypeScript, game objects, and then interface game object factory. So what TypeScript's going to do is basically merge the class definition and any interfaces that you create into the type in the end, so that you can use it in the IntelliSense, or VS Code can help you out. And so we're going to do that. It's going to take an X. Let's just copy this. It's going to take all those things and then return us a font. Beautiful. Okay, so we have here this.physics.add and this.add.font. Lovely. 128, 128. That, and we can ignore that. Okay, let's comment this out. And then, if you remember, we took this physics line. We'll just save it and see what it does. Come on. Okay. This dot. Oh, right. Right. It is indeed not a function because we did not import. So even though he gave it to TypeScript as a typing, it was actually not ever loaded. Okay. Target is undefined. Camera. Correct. Target is indeed undefined, because we need to do this, or yeah. Okay, there it is. So you see the bounding box is back to being giant, but otherwise everything works. So we didn't do this yet. We took this line into our .fauna class, and we commented it out. So we're going to now do it here because we can control this after the physics body has been created on our sprite. We can then do sprite.body, set size, sprite.width, sprite.height. Boom. Now, we couldn't do it in the constructor because in the constructor right here, there's no body, physics body hasn't added to it yet. So now this works. Great, and we have our player logic, or we have some of it in a class. We're going to move the rest of it into this class. So we can delete this. We don't need this. Let's see, anything up here we don't need? No. So the next thing that we can see that we can change is, of course, this update over here, right? There's no reason why this should be in the scene update. It only moves the player. And so here, let's put an update method, and we're going to take cursors. So phaser.input.events. Look, Siri came up. .events. What happened? No, .keyboard. No, .type. I always forget exactly where .keyboard. All right, cursor keys. All right, now let's go in here. We're going to copy all of this, roughly. I mean, all of it, not roughly, we're going to do that. Okay. So we actually only want to know that cursors is not null, where, I mean, this is not going to be null. And then if you remember in the previous video, in VS Code, you select the text that you want and you press Command D or Control D on Windows, I believe. It will then multi-select every instance or every occurrence of it. Okay. Well, we definitely don't want this anywhere, so I think I just delete. So I can have multi-delete. And then for this, okay, I didn't quite do it right, but this should still work. I'm going to select all these because this should now be this. So this multi-select editing. There we go. Now back here, we can get rid of that. So if not fauna for some reason, well, let me just do this. Let's just delete this. This dot fauna dot update, and we're going to pass in the cursor keys. There's that. We're going to get rid of this too shortly, so this still works. And now all of our input movement logic for the player is in the player class itself. So that's pretty good. Now for this hit. Let's say we're going to say handle damage. So just call it handle damage. And what we're going to want? We are going to want the direction, phaser.math.vector. We could also pass in the thing that hit her. Let's just leave it like this for now. We may want to for a more generic handle damage, but for simplicity's sake, just do this. We'll take that. Boom. No, we don't need this. And then this is going to be this. And let's see. So we don't want hit. What we're going to want to do is, how should we do this? How should we do this? There is a pre-update. So let's make a pre-update here. Then we're going to use a very basic state machine. We're not making an actual state machine, but for all intents and purposes, it is a state machine of sorts. Let's make a enum. I'm going to call this health state, let's say. Idle, damaging, taking damage. Just call it damage. Okay, two states. Private health state dot idle to start. This could also be healthy. I don't know. Idle it is. So here's what's going to happen. Hit handle damage. It's going to bounce back. This dot set tint. We're going to have to make a red. Okay. And then we're going to do health state dot damage. Okay. Now in pre-update, switch this dot health state. This is where the state machiney part of this comes in. Health state dot idle probably do nothing. And then case health state dot damage. So this is the taking damage health state. We are going to, since we have DT, which is delta time or change in time since the last frame, let's put in here damage time 0. And I guess when it starts, each time damage time should be 0. And what we're going to do is accumulate. So this dot damage time plus equals dt. This is a accumulator, this damage time property. And we're going to say if this dot damage time is 1/4 of 1 second or 250 milliseconds, we are going to do health state. Let's set us back to health state idle. Health state idle, and then we're going to untint ourselves red, so just white. It's the base tint. Just set damage time to 0. And then also in here, we can say, like, if I'm already being damaged, don't continue damaging me. So that you don't, like, when the player's playing and for some reason runs into like a horde of these lizards, the first one that hits them will damage them. You don't get like 10 damage here, 10 damage here, 10 and 30 damage. It doesn't quite feel right to the player, at least, even though maybe it is fair. It's not fun. Okay, so there's that. And we are also going to simply not allow you to move. Is that a good idea? I don't know. Let's see. If this dot health state equals to health state dot damage, don't do the movement. All right, let's see what this does. Hit me. I didn't get tinted because I didn't call anything. Sometimes you write out this code and then you just don't use it. Faune dot handle. Handle. What do I call it? Handle damage. It returns a faune, right? What's the issue? Oh. Right, we need to change this type to faune. So that was an auto import. If your code editor does not do that, do manually import the default export faune from the faune class. Okay, handle damage. We're going to pass in the direction we want her to move in. Come back, lizard. Boom. Oh, look at that. That's pretty good. So we can, of course, adjust that milliseconds time to see how long we want this damage animation, I guess you can call it, to last. Oh, freaking lizard. Okay, so that was damaging the player, and you see we did a little red animation after she gets hit. No, we should fix that. When did that happen? Well, okay, let me just do some cleanup. We don't need all these hits, all right? We put this in as a quick test, and we can delete that. We moved all our logic into the faune class, and so it's in update here. Run side. Let's see. Let's refresh. Is it because she gets hit? I don't know. Let's see what's going on. Run side, play. Ignore if playing true. Let's see. So one of the things when you refactor, you almost certainly, or not always, but sometimes you end up breaking something. I'm just curious. Does the animation play normally at all? No. Oh, did we forget a thing? Create character anims. Repeat, repeat, repeat. Okay, so this is a 25-minute video already. We will fix that bug in the next video because she's not quite walking right. And so this video, just to recap, we added the collision with the lizard and added a little animation, and we moved all of her logic into her own class. So come back for the next video. We are going to fix that bug and then add a little UI to show her health.